Okay, let's just dive right in. We're living in this era that I've started calling vibe coding.
Vibe coding, I like that.
You know the feeling, right?
Yeah.
You fire up Cursor or you're just throwing prompts at Claude, and suddenly you feel like a coding genius.
Oh yeah, the dopamine hit is real.
You're shipping features,
Yeah.
refactoring whole sections of the app, and it feels like you've hit, I don't know, warp speed.
It's an amazing time to be a developer for sure. That barrier between an idea and, deployed code, it's basically gone.
There's always a but.
And this is a big one. I hate to be the one to say it, but there is a massive kind of terrifying shadow hanging over all this speed.
I think I know what you're getting at. It's that cold feeling in your stomach. Did I just paste a giant security hole into my production app?
Precisely. We are writing code at the speed of thought, but our security practices, they're still moving at the speed of an annual audit.
Right. I mean, think about it. In a normal company, how often does a real human pen test actually happen?
If you're lucky, once a year.
Maybe. And usually only because a compliance check is coming up or something.
So you have this huge mismatch. You're deploying code, 5, 10 times a day, but you're only checking if it's secure once every 365 days. That gap is just impossible for people to close.
Which brings us to today's deep dive.
Mm-hmm.
We're looking at a tool called Shannon. And the sources, I mean, they're making some incredibly bold claims. They call it the red team to your vibe coding blue team.
And that's not just marketing. Shannon is a really fundamental shift. It's an autonomous AI pen tester, and that word, autonomous, is key.
So it's not just a script.
No, it's not a script you run. It's an agent that wakes up and decides for itself how it's going to try and break your application.
I saw a stat in the docs that just, it made me stop and reread it. There's this thing, the XBOW Benchmark.
Which is like the SATs for hacking AIs.
Right. And Shannon scored a 96.15% success rate.
That number is huge, but the context is even more important. That was a hint-free and source-aware test.
Hint-free?
Yeah.
Meaning no one was whispering in its ear, hey, maybe check the admin login page.
Exactly. It had to figure out the logic, the flaws, everything, completely on its own. That implies a level of, reasoning that we just haven't seen before in security tools.
Okay, but I have to play devil's advocate for a second, because I, like a lot of developers, have been burned by automated security tools before.
I know the type.
Yeah, it's usually just a scanner that screams at you about some library from 3 months ago, or it flags a variable name that looks suspicious but is totally fine. Is this just more noise?
And that is the absolute core difference here. Most of what you're talking about are SAS tools, static analysis. They're pattern matchers.
They look for code that lives like a vulnerability.
Right. And so they drown you in false positives. Shannon has a completely different philosophy, and it's summed up in 3 words. No exploit, no report.
No exploit, no report.
That sounds intense. It means it doesn't care if your code looks bad. It only cares if it is bad. It'll form a hypothesis, like, I think this input is vulnerable to an injection attack. And then it actually tries to do it.
Launches the attack.
It launches the attack. And if it can't if it can't prove the vulnerability is real, it just discards the finding. No report.
So if Shannon actually gives me a report, it's not saying, hey, you might have a problem over here. It's saying, I just broke in and here's a picture of me sitting on your couch.
That's a great way to put it, yeah. The output isn't a suggestion. It's a pen tester grade report, and it comes with a proof of concept, a POC.
So I can just copy and paste the exploit it found and see it for myself.
You run it, and you watch your system break. It totally eliminates that whole, is this even real debate that wastes so much time.
Okay, that is a game changer. But let's get under the hood. How does a piece of software, how does it think like a hacker? Hacking feels like an art. It's intuitive.
It is, but it's also a process. And Shannon's architecture is built to mimic a human pen tester's workflow. It uses this 4-phase loop that really shows how sophisticated these agents are getting.
All right, walk me through it. Phase 1 is reconnaissance.
Right. Now, back in the day, Recon was, running Nmap to see what ports are open.
Sure.
Shannon does that. It integrates Nmap, Subfinder, tools like that. But then it goes way further. It does live browser exploration.
So it's literally clicking around the website, like a user.
Exactly. It's navigating the app, and it's correlating the code it's reading in the repository with the behavior it's seeing on the screen. It's building a map. Okay, this function in the code leads to this button on the dashboard.
It's building context, something scripts are usually terrible at.
So once it has that map, it moves to phase 2, vulnerability analysis. This is the brain of the whole thing.
Okay.
It spins up these parallel agents. You can think of them like a team of specialists, and each one is hunting for a specific OWASP category.
So you've got one looking for injection, one for XSS, one for SSRF. The usual suspects. But how does it find them in a smart way?
It does what's called structured data flow analysis. It's actually reading the code, the abstract syntax tree. It traces user input from where you type it into a form all the way through the application to see if it ever ends up in a dangerous sink.
A dangerous sink being something like a raw SQL query.
Or an inner HTML assignment. Exactly. It's tracing the plumbing to see if it leaks. But here's the key part. The output of this phase isn't the final report.
It's not.
No. It's just a list of hypotheses. It says, I have a strong suspicion that if I send this specific weird string to this specific endpoint, the database is going to have a very bad day.
Which sets up phase 3, exploitation. This is the action movie part.
This is where it leaves all the old scanners in the dust. The agents take those hypotheses and they try to prove them. They use browser automation, command line tools, whatever they need to launch a real attack.
And the documentation mentioned it can handle some really tricky stuff here, like getting past a login screen.
This is where most bots just give up. Shannon can handle 2FA and even TOTP.
Wait, hold on. It can get past two-factor authentication? How?
Well, it's not magic. You have to give it the secret key in the configuration file. But once you do, it can generate the codes and log itself in. It can even handle sign-in with Google Auth flows.
That's a huge deal. It means it can test all the parts of your app that are actually important, the parts behind the login wall.
Where all the good data lives. Then finally, you get to phase 4, reporting. It gathers up all the successful exploits, throws out all the noise and the failed attempts, and generates that report with the reproducible POSI.
That sounds incredibly thorough. But I'm a show me the receipts kind of person.
Let's talk about the case studies. I want to hear what it actually broke.
The case studies are pretty wild. So first, they unleashed it on the OASP juice shop.
Ah, yes, the punching bag for security training.
Exactly. It's an e-commerce site that's just built to be hacked. But the question is, did Shannon just find the low-hanging fruit?
Right, like a missing security header or something simple. Not at all. It found over 20 critical vulnerabilities in one run. But the one that really stood out was a privilege escalation.
Okay, walk me through that. How did it manage to become an admin?
It analyzed the user registration process. It saw that the API for creating a new user would accept, it would accept parameters that weren't being properly checked on the back end.
The classic mass assignment vulnerability.
Yep. So it formed a hypothesis. What if I just add an admin, true flag, to my registration request? And it worked. It didn't just find the bug, it exploited it. It created a new user, promoted that user to admin, and successfully logged in. It took over the entire shop.
That is, wow. That is terrifyingly competent. What about the Camplay API example? That was from Techmarks, right?
Yeah, that one's all about API security. And there, it found a hidden debug endpoint.
Oof. Every developer's dirty little secret. The back door you leave for yourself to fix things later.
And Shannon found it. But it didn't just stop there. It used command chaining to bypass a deny list of forbidden commands and actually execute a root-level injection.
Root-level injection. So in plain English, it owned the server.
Pretty much. And it also found a legacy V1 API endpoint that was still running. The devs had locked down V2, but they forgot to turn off the old unpatched version.
That is such a human mistake to make. You put a new lock on the front door, but leave the back window wide open.
And one more, because it shows the technical depth. On OWASP API, it bypassed authentication using algorithm confusion on a JSON web token.
Okay, you're going to have to break that one down for me. What is JWT algorithm confusion?
So a JWT, that long string of characters you use for logins, has a header. That header tells the server, hey, I was signed with this super secure algorithm.
Right.
In an algorithm confusion attack, Shannon basically lies to the server. It modifies the token's header to say, actually, I wasn't signed with a secure key. I was signed with none. No signature at all.
It's like writing a check on a napkin and telling the bank, it's fine, the rules say you have to accept napkins today.
And in this case, the bank accepted the napkin. It forged a token, tricked the server into verifying it incorrectly, and walked right past the login.
The level of nuance that takes. I just don't associate that with AI. I associate that with some person in a hoodie who's been staring at hex code for 3 days straight.
That's the threshold we're crossing. The AI can now mimic that intuition. But to be fair, it also knows when it's beaten. In these same tests, it correctly identified a strong XSS defense. It tried, it failed, and because of the no exploit, no report rule, it didn't flag it.
It reported 0 false positives.
Exactly, and that's almost as valuable as finding the bugs. It builds trust.
For sure. If a tool lies to me, I'm just going to ignore it. Yeah, there is a big catch here we have to talk about, right? This is a white box tool.
That's right. It works best. In fact, the open source version only works if it can see the source code. It needs access to your repository.
I can already hear the security teams having a panic attack.
Mhm.
You want to give the hacker AI access to our code? Why? Why can't it just attack from the outside?
It could, but that's like fumbling around in a dark room. Shannon uses what's called code-aware dynamic testing. By reading the code, it's like turning on the lights. It can see a function and think, aha, that logic looks weak, and then immediately go test that specific thing in the browser.
So it's cheating, but in a good way. It saves time.
It's not cheating, it's an audit. And the efficiency is just staggering. A full run takes about an hour, maybe an hour and a half.
And what's the cost on something like this? I assume running these massive models isn't free.
It uses the Claude 4.5 Sonnet models, and the estimated cost is around $50 per run.
$50. I mean, compare that to hiring a human pen test firm. You're looking at 5, 10 grand easy, and you have to wait 2 weeks for the report.
It's orders of magnitude cheaper and faster. But, and this is a huge flashing red light BUT, we have to talk about the danger zone.
Yeah, when thinking about that took over the shop story. If it can create users, what else can it do?
The official warning on this tool is about as stark as it gets. Do not run this on production.
Why not? Is it going to crash the site?
It very well might. You have to remember, it's mutative. It actively changes the state of your application. It creates admin users. It might try to delete data to test if a delete function works properly.
Oh, God. I'm imagining waking up to find my AI just deleted the entire users table because it was curious about the delete account button.
Or it sent password reset emails to all of your actual customers. You have to run this in a sandbox, a staging environment that is completely walled off from anything real.
And legally, I'm assuming I can't just point this at my bank's website for fun.
Absolutely not. That's a felony. You need explicit written authorization to run this on any system you don't own. The Computer Fraud and Abuse Act is very clear on that.
Got it. No vigilante hacking.
No. And we should also be clear about the limitations. We're talking about Shannon Light, the open source version.
What does it miss?
It's focused on exploitable web vulnerabilities. It is not a dependency scanner. So if you're using a third-party library with a known issue, Shannon might not find it. It's not reading your package.json. It's testing your running app.
And what about hallucinations? LLMs are known to just make things up sometimes.
The no exploit, no report rule is the main defense against that because it forces the AI to show its work. But the sources are still clear. Human oversight is required. You can't just blindly trust the report. You still need a person to verify the findings.
So we're not quite at the fire the security team stage yet.
Not yet. The human's job is shifting from operator to supervisor.
It really feels like a turning point, though. The pro version is out there for enterprises, but the fact that this level of tooling is open source, it just changes the entire security landscape.
It really does. It lets security finally move at the speed of vibe coding. If you deploy 10 times a day, Shannon can run a pentest 10 times a day. It closes that massive feedback loop we talked about.
But it also opens this really big philosophical can of worms.
It does. I mean, zoom out for a second. We now have AI tools that can autonomously hack complex systems with a 96% success rate. Right now, we're using them for defense.
But the bad actors have access to AI, too.
Exactly. We are entering an era where AI writes the code, and a different AI breaks the code. It is an adversarial arms race, but it's being played out at machine speed.
And we're just the humans trying to keep up with the game.
We're becoming the supervisors of a digital conflict. And the real question is, as these tools get faster and smarter, will we even be able to follow along with what they're doing?
That is a very provocative thought to leave you with. If you want to check out Shannon, the repository is open source. Go read the code, spin it up in a sandbox. But please, for the love of all that is holy, keep it away from production.
Thanks for listening to this deep dive.
Stay secure.